Alright, good morning guys. Today we're going to learn about chapter 10.2 Loudness and Pitch of Sound. Our ears can differentiate the sound that are heard because sounds have different strengths and pitches, right? What is strength? The strength or loudness of a sound depends on the amplitude of the sound wave. Alright, we'll get into that later. Whereas the pitch of a sound will depend on the frequency of the sound waves produced. Okay? So, first of all, the strength in our case would basically mean how loud it is. Okay? If you have low strength, it will be very soft. And if you have high strength, it will be very loud. Okay? I'm not going to make it too loud. Alright, now something that you may not be too familiar of is the pitch of sound. What does pitch mean? Okay, pitch. Basically, it is the tone of the sound. Alright? So you can have very high pitch. This is not very high, but it's higher for me. Or very low pitch. This is pretty much as low as I can go. Alright? So you have high pitch and you have low pitch. That is how it sounds. Alright? Boys and girls will have different pitch. Everyone basically speak with different voices, right? And the pitch depends on the frequency of the sound wave produced. Alright, when we talk about the sound wave now, we are talking about how it's represented in a graph. Okay, you can see, for example, have you ever seen things like this? You may have in, for example, your WhatsApp voice chat. If you send a voice message and you play it, you can see the spike going up and down, something very similar to this actually. Okay, another way you may have encountered this before is if you ever use a voice recording program, and you may actually see something like this. Alright, but before that, let's have a play at this activity. Now, the aim of this activity is to study the effect of amplitude on loudness and the effect of frequency on a pitch. Okay, so they want to see the amplitude and loudness and frequency on the pitch. Now, how does this work? We use an audio signal generator. What this does is it will generate audio signals. Okay, we connect it to a loudspeaker so that we can hear what happens. Okay, and we connect it to a cathode ray oscilloscope. Okay, and this cathode ray oscilloscope will convert a signal from the audio signal generator into, it won't convert, it'll display the signal as a graph. For example, like this. Okay? Now, before we get into it, I want you to know that the amplitude is how high an object is, the graph is, from the equilibrium point, or the middle line here. Okay? So if you have, for example, if you can see here, this one is high compared to, let's say, over here. This one is low, right? And again, over here, you have a very high point here. You can do the top or bottom, doesn't matter. Let's just do top for simplicity. Versus something which is lower over here. Okay? So, in our case, we say amplitude will affect the loudness. So you can say that this part, let's call this A and B. So B will be louder, A will be softer. Alright. Now, we obviously can do this over here, but what we can do is use something called a signal generator. You can actually download it on your phone. I recommend you try it and play with it. Okay? So, what as a signal generator does. in our case, it will basically use our speakers to make noise. So we'll start off at 20 hertz. Okay, can you hear it? Let me increase the volume. Maybe not really, okay, because our ears are sensitive to like the low frequency, and 20 is pretty much the limit. Now if we increase it to like 60 hertz, can you hear this? Alright, so now I'm going to play with the amplitude. You can see the graph over here in the middle. Okay, if it is off, look what happens to the graph. If basically muted or no amplitude, it will just be a straight line. But if we increase it, the line will start to increase, and you'll see that the wave will go up and down and up again. Okay, so the louder it gets, the bigger the amplitude. The softer it gets, the smaller the amplitude. Now let's try something else. Instead of changing the amplitude, let's try changing the frequency. So we're right now at 63 hertz. I'm going to increase it to 125 hertz. See what's the difference. Okay, let me just increase the volume. 63, 125. Now I'm going to increase it to 250. And after that, 500. And after that, 1000. Okay, it's getting too loud. Okay, ignore how loud it gets. But I want you to look at the wave over here. See? At a 1000 hertz wave, alright? You can see that it goes up and down, up and down, up and down a lot, very rapidly. If we reduce that to like 250, you can see that it goes up and down, but not as much. And you notice that the pitch of it is a lot lower. Like 63 is very low, 250 is still low, but when we go to 500, it's getting higher, 1000 higher, and higher at 2000 hertz. Now I'm just going to stop this. Right? So that is basically your signal generator. The results that you get from this experiment will basically be the same as your handphone. So you can try that. Right? But in this case, output power would change the amplitude, and frequency, it changes the frequency obviously. Okay? So when you increase the output power, what will happen? The amplitude will increase. Frequency will change? No. Right? When you fix the output power and increase the frequency, what will happen? The frequency will basically increase, and the amplitude will also be fixed. Okay? So we can see change in sound by loudspeaker. What happened? This one will be louder, this one will be higher pitch, right? So as we can see from what our activity just now, if we increase the output power, we are actually increasing the amplitude, and when the amplitude increases, the sound is louder. Okay, and if we increase the frequency, what happens? Frequency obviously increases, and the pitch becomes higher. Okay, if we decrease the frequency, the pitch will be lower. If we increase the frequency, the pitch will be higher. Okay, now let's talk about the Doppler effect. Alright, the Doppler effect is an apparent change in frequency caused by the relative movement of sound source, the relative movement of the observer, or both. Okay, now when we say apparent, it means appears to. The frequency of the person inside this ambulance, for example, he will not hear the frequency change. However, this fella will hear the frequency change, or the sound pitch change. Okay, so apparent change in frequency means it appears to change in frequency or pitch if we're talking about sound. Okay, so for example, the frequency of the ambulance siren heard by the observer over here, which is stationary, he doesn't move, okay, increases when the ambulance approaches the vela. And the frequency of the ambulance siren heard by the observer, which is also stationary, decreases when the ambulance drives away from the observer. So, why is this? But can you even picture it? Okay, here's an example of the situation. You can see as an ambulance is approaching, you hear that the pitch will increase, and then as he goes away, the pitch will decrease. Okay? It is not the ambulance playing a different sound as it passes you. It is just that the pitch appears to change as it approaches, and as it leaves, the pitch will also change. Okay, let's see. So it goes away. What happened? Okay, as it approaches, frequency increase, hence what happened? The pitch also increase. Now, how about going away? Okay, as it goes away, the frequency decrease, and hence the pitch will also decrease. So this is the Doppler effect. There's a video that I'm going to link to you guys to watch for further explanation on this. Alright? So now let's look at this lastly, just to make sure you know what is frequency. Okay, among A, B, C, and D, and E, which one has the highest pitch? Highest pitch would be E. Why? Because the frequency is very high. This thing goes up and down, up and down, up and down, up and down, up and down a lot of times. Alright? And which one have the lowest pitch? We will have A. Why? Because this one goes up and down, up and down, up and down, not as many times. The least times actually. Right, that is all for chapter 10.2, loudness and pitch of sound. Right, thank you.